Okay, given the popularity of my first video, I mean relative popularity, I feel obliged to present to you another testing procedure, and that's the resistance measurement uh, of the knock sensor that I omitted mentioning in my previous vid. And so this is the computer that supplies 5 volts to the sensor, and because there are resistor, one in the computer, one in the sensor itself, in between the two there should be 2.5 volts with the connector plugged in. But say you don't have 2.5 volts, so what you do, I mean, you're back probing this connector, the wire that comes from the computer, okay? So you unplug the connector and there you have 5 volts, and you immediately know, hey, everything upstream, the wire that comes from the computer and the computer itself is all fine. So the problem lies downstream to the sensor, right? The sensor itself, or the ground, right? Following the logic. Anyways, what you should do next is measure the resistance of the sensor to be 100%, and you do it by, you know, connecting one lead of your ohm meter to the lower part thick wire of the connector for the thick wire is part of the wiring harness for the knock sensor, and that's why you probably need this socket with the slot if you want to replace it, because you put the cable or this thick wire through the slot. Anyways, the other lead goes to body ground. Okay, I don't know, maybe battery ground, but preferably body ground. Okay, I don't want to go in depth. Anyways, so the small current that the ohm meter sends either side is supposed to go through the circuit and circle back to the ohm meter, and you should measure 530 to 590 kilo ohm. That's the specification. Okay, and you should torque a new sensor 20 to 34 Newton meters or 14 to 25 foot-pounds. Yes, that's what I wanted to mention. And if you connect your scope here and set it to AC coupling, you will be able to see those 2.5 volts. And if you take a hammer and smack on the engine block, like a smack, 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 there you will notice the activity there, provided that the sensor is fine, the connector, the computer, the circuit is fine, and that's perfectly normal. That's what you should see, and if you zoom in closer, you will see that actually there's a AC sine wave on top of these 2.45 volts DC, and the stronger the smack, the higher the amplitude and the density or the frequency of the AC sine wave. And yeah, if you have that, I don't know, probably your sensor is okay. So yeah, and see, there's a voltage sensing circuit constantly monitoring, and he wants to see 2.45 volts there, and if it doesn't see those 2.5 volts, it will trigger the trouble code for the knock sensor. So yeah, mostly it is open in the sensor, so the sensor has to be replaced. But you know, it can be a connector, right? There could be some corrosion, right? And say there's complete open in the connector. You will read 5 volts here. Connector plugged in and connector unplugged, you know. So proper understanding of the circuit and how it works is essential. One more thing, when measuring the resistance, set your ohm meter right to the scale that is above what you're trying to measure, right? Above those 500 kilo ohms. So on my DVOM it will be like 2000K, because 200K is not enough, right? See, it's 2000K, 200K, not enough. 200K is not enough, so pay attention to that. Okay.